See, if you do not understand things properly, you should remember to see that whatever inputs and outputs are provided, those input and output should be connected. Now I am showing you the series of T flip-flop. All of you draw along with me, then only you will understand. What you can see in this, the first T flip-flop clock is connected with count pulse. And this count pulse you can assume as a clock only. And the input of this flip flop T and all the input of all the four flip flop is all the input of all the flip flop is connected together and all will toggle together, right? So all the T flip flop input is shorted together, it is shorted together and it is connected to a input which is called as count enable. So if count enable is 1, all the toggle flip flop will toggle together. All of the toggle flip flop will toggle together. Okay. So it is count enable 1 means all the flip flop will toggle together. Now toggle together means what? It can toggle only if it gets the enable signal. You all know that enable signal means what? The flip flop operates and this clock is nothing but it is used for the controlling your flip flop. If you make available your clock, then only it will work, right? So when I am putting this bubble, when I am putting this bubble means I am showing the connection with Q bar. I am showing the connection with Q bar. This is very, very important. You people have not understood the exact point which I wanted to tell you in the last class. Now you see this Q bar is coming and connecting to the next flip-flop clock input. Can you see? So my second flip-flop, I will call it as okay, let me call this as second flip-flop only. The second flip-flop, the enable signal is connected to the previous flip-flop Q bar. So that means what? This second flip-flop will work under two conditions. If your count enable is 1, then it will work. Otherwise, it will also work when count enable is high as well as Q bar is, this signal is available at the clock. So second flip-flop is being controlled by first flip-flop. In turn, second flip-flop is controlling third flip-flop because control signal is inputted by the output of second flip-flop. Same way, the third flip-flop is controlling the fourth flip-flop control signal. Now, when I am taking the output from each one, Q0, Q1, Q2 and Q3. So what is happening? If I show this count pulse as a clock pulse, okay. Now all of you look into this waveform very, very carefully, what I am making, and all should make it along with me. Okay. All should make it along with me. Try to make it properly because otherwise you will not understand anything. So I am making a clock signal which is given as count pulse, which is given as count pulse to the first flip-flop only. And you can see that the first flip-flop count pulse as clock and the clock is active high enable only. Clock is active high enable only. So the waveform what I am making is the waveform which is given to the first flip-flop only. That is count pulse. Count pulse is nothing but clock signal. Count pulse is nothing but clock signal. This is what I am giving to my first flip-flop. Okay. Now you have to look into first flip-flop only. Okay. And this count enable is made high for all the time. Assume for rest of the operation count enable is high. So what will happen? Every time this positive pulse of this count comes, the flip flop will toggle. Why it will toggle? Because it is toggle flip flop only. It is T flip flop. Now all of you look into the waveform what I am drawing. So you see on the screen properly, at this positive pulse, Q naught will come and toggle. And when it will toggle again at the next positive edge. Next positive edge, it will toggle again. Again, it will toggle at the next positive edge only. What do you mean by positive edge? Positive edge is the place when the clock changes from 0 to 1. 0 to 1 is called as positive edge. So at these edges only where I am making these arrows, only at these arrows the output will change. Output will toggle. If it was 0, it will become 1. If it was 1, it will become 0. So on it happens like this only. So this is my output of the first flip flop. Input of the first flip flop is count pulse. Output of the first flip flop is this toggle signal. So what you can see is this toggle signal is having the frequency as half of the previous waveform. So count pulse CP, count pulse frequency is double of this output. You can, you know, na frequency. What do you mean by frequency? So this is my Q naught. This is my Q naught, right? Next, after Q naught, what will happen? I have my first flip flop operation I have shown. I got my Q naught. Now Q bar is activating my next flip flop. So when Q bar is activating my next flip flop, what will happen? It will toggle my second flip flop, this flip flop, when it will toggle at the negative edge. Why negative edge? Because Q bar is connected as the clock input. Because Q bar is connected as the clock input, that is why it will toggle only at the negative edge. Now I have to show the toggling at negative edge. So let me mark my negative edge of Q naught. So Q naught bar is something which is activating my second flip flop. So now if I make my Q1, what I will do, I will change its state at every negative edge only. I will change its state at every negative edge. So what you can see now is that the frequency of Q1 became even half of Q naught. So frequency is keep on changing, right? Frequency is keep on changing. So I hope you have understood. Is this clear what I am doing with these waveforms? I need your feedback to understand whether you are understanding what I am saying.
Yes, ma'am.
Yeah, okay, good. So you are able to see that for Q naught toggling happened at positive edge, but for Q1 toggling happened at negative edge. Why that happened? Because for Q naught flip flop, the toggling was happening based on the count pulse, which was positive. But for Q1 toggling happened at negative edge because Q bar was connected as the pulse, as the clock pulse. Now, same will happen for Q2. We have to look in for negative edge only again because Q1 bar is connected to the third flip flop. Again, I will see that the toggling is happening only at the negative edge. Toggling is happening only at the negative edge. Now what will happen for Q3? What will happen for Q3? Again, I have to see my negative edge only because Q2 bar only is connected to my last flip flop. So it will keep on at 0 and at negative edge it will become high. Now I want you to look into this waveform carefully after completing this waveform. Now you see, I will ask you to name it. Name it means what? You see what is happening in this column. What is the value of Q naught, Q1, Q2, Q3? Q naught is a 0. Q1 is also a 0. Q2 is also a 0, Q3 is also a 0. What is happening at this? See, this is in the beginning of this count pulse. What is happening in this time period? See my mouse where I am pointing. At this time period, between this positive and this negative, I am talking about this time period. I am talking about this time period. What is happening in this time period? Let us check. Q naught is a 1, Q1 is a 0, Q2 is a 0, and Q3 is also a 0. Right? Now let me see at the next clock pulse. Next count pulse, what is happening? In next count pulse, this is a 0, Q naught is a 0, Q1 is a 1, Q2 is a 0, and Q3 is also a 0. Can you see? Now I will check my next pulse. What is next pulse? This is my next pulse. Each pulse of this count pulse I need to check now. Now when I am checking this count pulse again, what is happening? This is a 1, this is a 1, this is a 0, this is a 0. Right? Are you able to see how I am writing this 1100 and all? Now at this clock pulse, see my mouse, at this clock pulse what is happening? This is a 0, this is also a 0, this is a 1, and this is a 0. Again next clock pulse, this is a 1, this is a 0, this is a 1, and this is a 0. Can you see? Same way, keep on doing it. Now this is a 0, this is a 1, this is a 1, this is a 0. Again, next one, 1, 1, 1, 0. Next, what is happening? This is a 0, 0, 0, 1. Right? Again, this is a 1, this is a 0, this is a 0, this is a 1. Last one. Last one, this is a 0, this is a 1, this is a 0, this is a 1. Right? Now I want you to read it. How I want you to read? I want you to read considering Q3 as MSB and Q2, Q1 and Q0 as MSB. I want you to read in this fashion. Q3 is MSB, Q0 is LSB. Now read. When Q3, Q2, Q1, Q0 is all 0, what it is? It means it is a 0. So when I name it here, Q3, Q1, Q2 and Q0 all are a 0. Then what is it? This means it is a 0. Now next you see what it is? 0, 0, 0, 1. So what is 0, 0, 0, 1? It is a 1. Next you read here. What it is? 0, 0, 1, 0. So what is 0, 0, 1, 0? 0, 0, 1, 0 is a 2. So you can see now 0, 0, 1, 1, 3 you got. 0, 1, 0, 0 is a 4. Right? I hope you people remember this. Okay. So let me write it down to the waveform only. So this 0, 0 is giving me a 0. Then 0001 is giving me a 1. 0010 is giving me a 2. Then what is happening? You can see here 0011 is a 3. Then 0100 is a 4 and so on. 5. Then what you see 0110. This is a 6. Right? This is a 6. Then 0111, that is a 7. Then 1000 is a 8. Then 1001 is a 9. 1010 is a 10. My waveform did not complete, but if you take a landscape page and take it further, you will see that it will go from 10, 11, 12, 13, 14, 15 also. You can see. So what you can see is if my toggle flip-flop are connected in a series manner like this, where the negative or Q bar is connected as clock pulse for the adjacent next flip-flop, it gives rise to a up counter. It gives rise to a 4-bit binary ripple counter which counts up. Are you understanding this? Did you understand what I have explained with the waveform and so on? Yes, any doubt in this? Say yes or no, Baba.
No, ma'am.
Okay, so did you understand this part?
Yes, ma'am.
Okay, now I want you to do the same thing again, which I had asked you as the homework in Google Classroom, but I could not find a single correct answer. So I understood that you people need the teaching again. Now, I hope you know the connection again now. What will be the connection? Connection will be connecting from which, whether I will connect from Q or Q bar. Yes, tell me.
Q, ma'am.
In the previous circuit, we connected from Q. Now this circuit, we will connect from Q bar. Right. Now I have to show you what changes. What changes by one simple connection. What changes. So I will show you that. Of course, this is first time you people are looking into these things. So it may be difficult for you to understand at once. So I need to explain in detail. So for the first one, as before, the clock pulse is going. For the next one, you have to see now the output is taken from the Q. Output is taken from the Q, and Q bar is left idle. Q bar is left idle. So now we will show that the next clock pulse is being, it is being connected with the previous Q only and not Q bar. Previous Q only and not Q bar. So we will show that connection. Okay. Now I will take the output also from Q only. So Q0, Q1, Q2, Q3. Okay. So this is the connection, and your Q bar is left like this. Okay. Q bar is left like this. Now let us see what happens. What change happens. Okay. So now again I have to make the same clock pulse the way I had done before, and count enable is always 1, so that toggling happens all the time. And the first waveform what I am drawing is nothing but a clock. It is a clock. You should see to it that it has same width. All of you draw along with me. I will be asking any one of you to show it also. Okay, so this is my clock pulse, which is the input clock pulse of only the first flip flop. Okay, now what I am showing now, I got this as input. Now Q naught is toggling, and as it toggled for the previous waveform, it toggled for the positive pulse. There is no connection change in this. It will toggle at positive edge only, because my clock pulse is active high clock pulse only. So I am marking this positive edge, and I will show the toggling only at the positive edge. So let us show the toggling only at the positive edge. Okay, all of you make this waveform along with me. So let us toggle it only at the positive edge. So this waveform is Q naught waveform, right? This waveform is Q naught waveform. Now the change comes. What is the change? Change is now this Q naught is activating or enabling my second flip flop. So now the toggling of Q1 happens at the positive edge. So let me again mark my positive edge. I am again marking my positive edge so that I can show the toggling for that only. Okay, so let me show it. I am showing the toggling at the positive edge only. So you saw toggling is happening only at the positive edge. So wherever you have your positive edge, there only toggling is shown, right? This is my Q1. This is my Q1. Now let me show my Q2. What will happen for Q2? Q2 also toggling will happen only at the positive edge. So I need to mark my positive edge again. So let me show the toggling at the positive edge again. So you can see toggling is happening only at the positive edge, right? Now this is my Q2. What will happen for Q3? Q3 also toggling will happen only at the positive edge. So this is positive edge and this is positive edge, right? So toggling will happen there only. So let me toggle at this positive edge, toggled, and the next positive edge is coming after a very long time here. So you can see the frequency of the Q3 is half of Q2 and Q2 is half of Q1, Q1 is half of Q0 and Q0 is half of count pulse. Now let us do the numbering naming the way we were doing before. The numbering and naming the way we were doing before. Now let us see at the first count pulse. What is Q0? Q0 is a 1, Q1 is also 1, Q2 is also 1, Q3 is also 1. At the next one, this is a 0, 1, 1, 1. Next one, this is a 1, 0, 1, 1. Right? Next one, this is a 0, 0, 1, 1. Right? Again, 1, 1, 0, 1. Right? Again, 0, 1, 0, 0. Right? Then, sorry, you should correct me if I am doing something wrong. Okay, this is 1 only. Next, 1, 0, 0, 1. Again, 0, 0, 0, 1. Right? Last, 1, 1, 1, 0. And one more I can show, that is 0, 1, 1, 0. Now, can you read it again? The way you read for the previous page. Previous page, how did you read? You have to read this Q3, Q2, Q1, Q0 only. The bits you have to read and name, right? So now I am reading Q3, Q2, Q1, Q0. For the first case, what was your Q3, Q2, Q1, Q0? All were one only, right? All were one only. And when I bring all one means what? It makes a 15. And what is the next one? It was a triple 1 0. And what is triple 1 0? Yes. What is triple 1 0? Is it not 14? Next is double 1 0 1. You have to read it in this fashion only. Q3 as MSB and Q0 as LSB. So what is 1101? It's a 13. So here I will write, this one is 15, 14, 13, 12, right? 12, then 11, then what is 1010? 1010 is a 10, 1001 is a 9, 1000 is 8, 0111 is 7, 0110 is 6. Now again you can see that if I would have continued my waveform, it would have gone till 5, 4, 3, 2, 1, 0 and back to 15. Okay. So here it will go till 0 and after 0 it will go back to 15. Again it will start from 15. So this binary ripple counter, how many states it has? Somebody should reply me. How many states it has? Yes, fast.
4, ma'am.
4. See, I will show you here. 4 is not a right answer. See, up counter. When my four bits for were all 0000, it was in the state of 0. When it became 0001, it was in the state of 1, and then state of 2, then state of 3. Of course you are telling 4 because you saw that there were four variables, q0, q1, q2, q3, but these four variables were able to give me more number of states. So how many states it was? Yes, anybody can attempt to answer. Yes. In the up counter, in the up counter, it counts from 0, 1, 2, 3, 4, 5, 6 till 15, and then it comes back to 0. So how many circles are there? That many states are there. So when I had four variable of q3, q2, q1, q0, it is able to give me 15 states. And what are those 15 states? It is 0 to 15. And once you reach 15, it resets to 0, and again it starts counting up counter. So with those four toggle flip-flop and that type of connection where Q bar was governing or controlling the next flip-flop, it gave me a up counter. When I had connected Q, the Q for the flip-flop as the controlling variable for the next flip-flop, it became a down counter. So these two are very important thing for you people to understand. Up counter state diagram I have shown. You can make a better circle. You can make a better circle. Of course, I could not make that neat and clean diagram. Let me also try. So this will be for down counter. Again, what will happen? 15, 14, 13, like this. You will get your counter starts from 15, right? You saw there, no? It starts from 15. And what is happening after coming to 1? It comes to 0, and again it goes to 15. So the counter for the down counter is 15, then 14, then 13, 12. Like this it goes on. Like this it goes on, and it will be coming back to 15. So this is the state diagram of down counter. So state diagram of up counter shows that we have 15 states. After it reaches 15, it comes back to 0. And same way down counter, it starts from 15, goes to 0 and goes back to again 15. So this is up counter and down counter. So this should be clear to all of you. Okay. Now what I have given you now is a asynchronous counter. Now what is the difference between asynchronous and synchronous? In this diagram, what you can see, all the flip-flops are not working together. Can you see? When my first flip-flop is working here, my Q1 is still not working. It is waiting for the positive edge to work. So all the flip-flop are not working at once. So this is called as asynchronous. This is called as asynchronous counter. When all the flip-flop are not working together. Now, there is a problem with respect to this. What is the problem? Problem is in asynchronous counter, if you have a delay or propagation delay of one flip-flop is more than another flip-flop, everything becomes a problem. That is why asynchronous counter are not a popular counter for any application. Everybody likes to work with synchronous counter only. Now why everybody likes to use synchronous counter only? Because all the flip flop will work together. Now you can see that we had seen this one. Of course, in the book they had not given the waveform for the down counter, which I explained you just now. Now you have to see the my this binary counter only. If I want to make synchronous, what change I have to do? So all of you see on the screen, I am talking about synchronous binary counter, and you can see that I am talking about the similar circuit what we have seen just now. Only a small change is there, that your flip flop is not being connected to the previous flip flop. Now you see what is happening. All the clock pulses are connected together. All the input clock pulses are connected together. And if this count pulse will be given to all together, but toggling, when it will happen? Toggling will happen with respect to your Q0, Q1, Q2 only. And this means what? Will it be up counter or down counter? Somebody should tell me. The circuit shown on the screen, is it a up counter or a down counter? You can see that toggling is happening through this Q0 only, Q1 only, Q2 only. But my second flip-flop toggling is happening when your count enable. See, count enable will always be high when it is working as a counter. It will always be high. Okay. So all the count enable, this will be high. Now when this will toggle, it will toggle only when Q0 positive edge is coming. When this will toggle, it will toggle when Q0 as well as Q1 positive edge is coming. And this will toggle when all the three positive edges are coming. Now you check in the circuit, and check in the circuit for the positive one. You can see here Q3 is toggling when all the positive edge has come here. And what about Q2? Q2 is toggling when Q0 and Q1 positive edge is here. Can you see here? Q2 is toggling when Q0 and Q1 positive edge is here. Same way, Q1 is toggling as the positive edge of the previous one. So you can have the similar type. What it is telling, that the previous flip flop will toggle at the positive edge of the all the previous flip flop, not only one. In this case, only one positive edge was controlling. But in this diagram, what you can see, all the positive edge, all the positive edge will be together making the control of this toggling. So this becomes a synchronous binary counter. Why synchronous? Because all the clock pulses are connected to the same. So all the clock pulses are synchronous to each other. That is why it is called as 4-bit synchronous binary counter. But the functioning is same as the previous one. Now one more variation is shown. One more variation is shown, and that variation is here. Can you see here this? This variation, what is the variation? In this, we are not taking all, but we are taking only previous. But this is going into an AND gate, your Q0 and the count enable. Q0, this one, toggling of the previous one as well as the Q1. So this will become high only when the positive edge of this will come as well as positive edge of this will come. So this is just a variation. The waveform will be same for all these variation circuit, because it will toggle at the positive edge only. So whether it is directly put for toggling, or whether our 2-3 signals are brought together and put in AND gate and for toggling, all are together. All are together. Okay. So this is another variation of down counter only. Okay. Now I would like to show you one more circuit. Okay, this one is a mod 10 counter. Mod 10 counter. You people will be using this circuit for your lab also. So let us understand this circuit. This circuit, internal circuit is given here, this right hand side, but you need not bother about internal circuit. As of now, you understand this. So what it is, it says it can load. Now when it says mod 10 counter means what? It will have only 10 states. 10 states means what? It will have only 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 will make it 10 state circuit. 10 state circuit means 10 state circuit means it will be having only 10 states. Now, what shall I do after 9? If my normal counter is there, it will not stop at 9, it will go till 15. So, what is happening in this circuit? We get a 9 here. At 9, what happens? Both Q3 and Q0 is 1. You can see here in the counting sequence. Q3 is also 1 and Q0 is also 1. And only for the state of 9 only, Q3 and Q0 will together be 1. Before that, you will not see any state where Q3 and Q1 are 1 together. So that means what? As soon as this 9 occurs, as soon as this 9 occurs, this connection of Q0 and Q3 together will go and give high signal to this load input. It will give high signal to this load input. And what this will do? It will load this counter with whatever is available at this D0, D1, D2, D3. Now what you can see, what is available at D0, D1, D2, D3? All are connected to a 0 here. All are connected to a 0 here. So what will happen? As soon as 9 comes here, as soon as 9 comes here, this will go and activate this load, and this load will load this 0. And because this is a up counter, as soon as this loading of 0 happens, it will again start counting from 0 only. So 0, 1, 2, 3, 4 till 9 it will come, again this will come. So this becomes a counter of 0 to 9 only. Okay, so this is called a synchronous mod 10 counter or synchronous decade counter. So this is one IC which is used in your lab also, and you will be using it for your experimentation. Now, if I want something more, I don't want 4-bit count. If I want 8-bit count, what can be done? See here, this right hand side circuit. What can be done? These are my two 4-bit count, and option is available for this CO. CO is count output. Count output. And it will come here and it will be able to give me this 4-bit and this 4-bit. So this can be cascaded like this. So Q0 to Q7 you will get, and this will become a 8-bit counter. So this is a 8-bit synchronous counter constructed by cascading to 4-bit counter. So these are available ICs in market which can be customized for our own application. So this is about your simple counter cascading for more number of bits rather than 4-bit. Okay, counter based on shift register we had discussed in the previous class. That is your modulo 4 ring counter, modulo 7 twisted ring counter, and modulo 8 ring counter. In the next class we will work upon design of synchronous counter. Okay, we will see how to design, because whatever counter you can see now, it will count from 0 to 15 and 15 to 0. We do not have much apart from that. But when we do synchronous counter design, it will be customized to the user's choice of from where to where you want to count. This will be more complicated but interesting. So we will see that in the next class.